Let's consider a ring, and here we have radius r, and we want to find out the electric field along the x-axis. So now let's say we have a segment of this dq, and you can see this will produce dE in this direction, and you always can find another segment that able to cancel out the electric field in the y component. Now let's this part define as data, and from here to here, let's say this is x, and this is small r. So this ex, and ex is given by here, which is the electric field in the x component. Then the y will be cancelled out. We don't consider that. We don't need to consider that. And integrate dq per r squared cos theta. Now you can see from here this r is given by the square root of capital R squared plus the x squared. Now we substitute this inside, we get r squared plus x squared. The cos theta is given by the adjacent over the hypotenuse. Our adjacent is x, and our hypotenuse is the square root of capital R squared plus x squared. It's just this small r. We express in terms of this capital R and x. So uh, 3/2. Now the charge density lambda is given by dq over dl, let's say. Now so dq is equals to lambda dl. This is x lambda dl per this r squared x squared. Now what I mean by the integration of this dl? Actually this is we want to find out sum out this form a segment, very small segment. Let's say this is dl, and we want to sum out this dl until it form a ring. So the arc length formula is given by this r phi, and phi is any reference point, let's say here until anywhere. The angle from any reference and start rotating around, you can see here. But of course this is dl, so dl we can write this is r d phi, and now we substitute inside here. This is x l r d phi over this r squared plus x squared 3/2. And what is the range we want to integrate? In our case, we want to form a complete ring, right? So we must start with here and rotate until back to here. That means we have to sum out this dl all along this, which given by from 0 uh, a complete circle, so to 2 pi. Now from here you can clearly see the result. This is given by the lambda 2 pi r x, and this is one thing you can see this lambda 2 pi r here actually is given by the total charge, which is let's call it q. Q is the total charge equals to lambda 2 pi r. So here this is 4 pi epsilon and qx over the r squared plus x squared 3 over 2. Now we only solve for one ring. We have a two ring, and in this derivation, we actually treat this point here, the center of a ring here, to be the origin. So from for our case, you see here the diagram. The origin is not at the center of a ring, so we have to do some modify. This is why this is R, and this is given by L over 2. Now from here to here is also given by L over 2, and let's call this ring to be the first ring. You can see this the center of this ring here uh, is located at a negative L over 2 for this new origin. So we have to make the modify on this equation. This x should be changed to x minus L over 2 for the first ring. The reason is we want to shift this origin to the new site, which is here. We want to make it for the new origin. Now for this electric field due to the first ring is given by this 4 pi epsilon, and this is q and x minus L over 2, and this is r squared plus this x minus L over 2 squared 3 over 2. Now how about the second ring? You can see the second ring is basically the same, but now the second ring is located at this positive L over 2. So for second ring, this x should be replaced by the x plus this L over 2. Of course, the same reason. This is a q, and this is x plus L over 2. And this is r squared x plus L over 2, 3 over 2. Now, how about the net electric field? So this is E1 plus E2, and we can write this is a Q for pi epsilon naught, and that's this whole thing x minus 1 L and r squared plus x minus 1 L squared, this whole thing 3 over 2, and plus x plus 1 over 3 L, and this is r squared plus x plus 1 over 2 L squared and 3 over 2. And if you like, you can define the direction. Now, this is the answer. Anything we can verify whether this is the answer or not. And one of the classical thing we can do is this. We try to find out the electric field at this point. Remember, we already discussed on this. The electric field are only in this x direction. You can see they are both have a charge q, right? And this from the first ring, the electric field will go like so, and the second ring, the electric field will go like so. And since this separation distance and this charge is the same, we should expect at this part, this origin here, the E should be equals to 0. This is one way we can verify our answer. So we try to substitute this x equals 0 in our formula. So you can see if x equals 0, from here you can see this x equals 0. So the result we get is 3 over 2. And the thing should be mentioned here, you can see this is a negative inside, and square of that you will get this will equals to the 1 over 3 square, because you square a negative you will get a positive result. And you can see we plus this 1 over 2 L, and this is r squared plus x is 0, 1 over 2 L squared. This is 3 over 2. You can see the whole thing is exactly the same, only here have a negative sign. So the whole part here, we will get this is 0. And so this E field at the origin there will equals to 0. That means this is consistent with our intuition. So this is one way you can try and verify your answer.